So hello friends, today we are going to discuss about how to find the impedance, that is Z of S, for this network. So as you can see, the network is only a one port network. There is other port is closed, so this is a one port network and we have to find the impedance Z of S. In order to proceed with this, you need to do Laplace, convert this network into a Laplace. Do Laplace means convert this circuit, convert this network into Laplace domain. Okay, so you need to understand, you have to remember this. Resistor's Laplace will be resistor, capacitor Laplace will be 1 upon Cs, inductor Laplace will be inductor into S. You need to understand these three basic concepts. Okay, so having said that, let's go with it. Draw your circuit, capacitor, resistor, and we have what you have, inductor. Okay, so capacitor, see this 1 upon C of S. So capacitor is C, 1 farad, 1 upon 1s, so it will be 1 by S. Okay, resistor value will be 2 only. Resistor does not change. What will change? Inductor value 1 by 2 Henry, 1 by 2 H, so it will be 1 by 2 into S, so it will be S by 2. Perfect. So these are my values, and then you need to analyze the network. First step has been completed. Now second step, you have drawn it in the Laplace domain. Now second step goes like this. As you can see, this 2 ohm resistor and this inductor are in parallel connection. So you can write simply 2 parallel S by 2. So what is 2 parallel S by 2? 2 multiplied by S by 2 and 2 plus S by 2, which gives you 2S by 2 upon, you will cross multiply it, so 4 plus S by 2. This 2 and this 2 in the denominator gets cancelled and you are remaining with 2S upon 4 plus S. 2S upon 4 plus S is your value for this resistor and inductor. Now let's redraw it. You have your capacitor over here and I will draw a impedance box. Remember, impedance box is drawn when you have two different components, resistor, inductor, or resistor, capacitor. You need to draw impedance box. The value for the capacitor is 1 upon S, and the value of this impedance box, which I have calculated it as 2S upon 4 plus S. We'll write 2S upon 4 plus S over here. This gives you, so now as you can see, this capacitor and this impedance box are in series. So series combination, will write it series combination. This is my third step, series combination. Every numerical will have different set of steps, but the concept remains the same. You need to follow it in every sum. So 1 upon S is in series, so I will add them. Now. So after how to add this? The denominator is not same, so we'll cross multiply it. 4 plus S will cross multiply, and S will cross multiply with 2S. So S and S is here, so 2S square. So it will be 2S square upon the denominator. What will be the denominator? S multiplied by 4 plus S. So this is how you get your values. Now writing the 2S square first, term first, then S, and then 4, and you can open the brackets. You will get S square plus 4S. Okay, you will get this after you multiply 4S and S square. Okay, and this is your final value of Z of S, which I want to find out the impedance. The impedance Z of S, I got it very easily. See, there is nothing in this sum. Just convert it into a Laplace domain. After converting into Laplace domain, apply series parallel combination. This is parallel combination. We multiply and addition. We do addition. So you will get this value. After you get this value, draw impedance box. After drawing my impedance box, my capacitor and impedance box are in series. For series, you just add the two values together, 1 upon s plus this value. So do the required what you can say mathematics and get the value of z of s. After getting z of s, we have to find out the poles and zeros. Now remember, poles and zeros for z of s, you can see the numerator will consist zeros and the denominator will have poles. Always remember, denominator has poles and numerator has zeros. So poles, for finding poles, let us write it over here. For finding poles, s square plus 4s, we'll take it as 0. Take s common, so you will get s equal to 0 and s equal to minus 4. These are my values for poles. Simple, denominator value equals to 0, then you take common and then you get the value. Perfect. So these are my poles. I will also calculate for 0. For this you need an calculator. Okay, so let's take the calculator and switch on to your equation, and then as you can see, I will take third equation. Let's check equation. I will take the third one. Okay, so I will select third. Here you have 2, then s value is 1, and here you have 4. 2 and 4 will type it in the calculator and you are getting something like this. As you can see, minus 1 by 4 plus root 31 by 4 I. So let us write the values. 2s square plus s plus 4. After solving it in calculator, solve it in calculator. Okay, after solving it in the calculator, I will get my values to be minus 1 by 4 plus root 31 by 4 I, and other value is minus 1 by 4 minus root 31 by 4 I. Okay, so we'll get here two values. So just do one thing. Simplify this further by just calculating the proper values which we'll get. So let us write this. Minus 1 by 4 is 0.25 minus 0.25, and this value again will calculate it, root 31 by 4. So it gives you 1.391 I cap or j. Let's take j. So plus, this is my first value. Second value also I will write it like this, minus 0.25 and minus 1.391 j. So these are my two values after solving it in the calculator. I just did 1 upon 4, the value comes out to be 0.25, and root 31 by 4 gives me 1.391 j. So after getting these values, we will plot the graph, that is pole 0 graph. Let's plot it over here. Let's plot it. You need to draw two axes. This is your imaginary axis, j axis imaginary, and this is real axis. So s equal to 0 is my pole. Okay, so mark it with a cross sign. and similarly you can see s equals to minus 4. So minus 4 will lie over here, minus 4. These are my two poles, 0 and minus 4. First mark your poles. Then second, we will calculate this, minus 0.25. Okay, minus 0.25 will lie something here. This is minus 0.25. Let's take this, minus 0.25. And for imaginary is 1.391. Let's take positive. So it is 1.391. And this is your negative, minus 1.391. Perfect. Draw these two values in your graph for the imaginary axis and then join it together. So this value gives, this is 1, this is 2, this point connecting this 2, and you get your final z of s. Okay, so this is for the graphical representation. So that's all for this video. Thank you so much for watching this video. I hope you understand this topic. Thank you.